question asks us to draw all additional resonance contributors for this molecule, looking for pushable pairs of electrons and an adjacent place to push them. There are a couple of pi bonds, a couple of lone pairs. What I'm drawn to is the carbon with the negative charge. That is the least stable position in the molecule and a good place to start a resonance series. I have a pushable pair of electrons in the lone pair, and I can push it toward the alkene. So I can take this lone pair and I can use it to form a pi bond between these two carbons. That would build up too much electron density around this carbon, so I can take this pushable pair in the alkene and use it and deposit those electrons locally onto carbon. That will form a new resonance contributor with a new lone pair and negative charge on this carbon. Now I can look again, see if I have any more pushable pairs of electrons and places to push them. Again, my eye is drawn to the negatively charged carbon. That's the least stable position in the molecule. I can take these lone pairs of electrons. I could push them to the left or to the right. If I push them to the right, that would just bring me back to the original structure. So I'll push them to the left and form a new pi bond between these two carbons. That will build up too much electron density around this carbon, so I'll need to break the carbon-oxygen pi bond and deposit those electrons onto oxygen. That will form a third resonance contributor. At this point, pushable pairs of electrons will be the electrons on oxygen. Wherever I push them, though, I'm going to regenerate a previous resonance contributor. So this concludes the resonance series. These are all the additional resonance contributors for this molecule.